We now have the knowledge required to solve a model. If we have a model, now let's focus on how to develop a model for a simple mechatronic system. Example I'm using is a rod connected to a DC motor. We can consider the rod as having a mass of zero point 0.5 kilograms, a length of 200 millimeters, and that the rod is uniform with respect to cross section and mass distribution and so on. The motor is a common permanent magnet brushed DC motor, which is sold under the brand 775, and we'll operate it under a constant voltage power supply of 12 volts. The rod will be at rest prior to power in the motor, and the objective of developing this model is to evaluate the motion of the rod after the motor is powered. Well, I suggest you read through this. Let's first draw a free body diagram. Draw the rod, mark the pivot point O, then draw the horizontal axis. Now you will notice the only degree of freedom, the rotary degree of freedom, and we mark it as theta with the anti-clockwise being the direction of the positive rotary direction. Anti-clockwise or counterclockwise. Both have the same meaning. We can define our objective as to obtain a function for theta with time as the independent variable. So function would be of the form theta equals f of t with theta as the dependent variable and t as the time. Well, stage 1 drawing the free body diagram is done. Now let's mark the interactions between the devices of the system. I hope you can remember from our first lecture that a system is a collection of interacting devices, and the interactions happen between the devices themselves and between the devices and the environment. So I'll first mark the interactions between each of these devices and the environment. With respect to the rod, gravitational force acts on the rod. Here I have marked the magnitude of this force and the line of action, and it acts. We kind of simplify it as acting on the center of gravity. We have done so. So there are no, AR resistance also acts as an interaction between the device, the rod device, and the environment, but we neglect it for simplicity. So therefore, we haven't marked it. So that's it for interactions between the rod device and the environment. Now we move on to the motor. The interaction between the motor and the environment is that it's powered using a 12-volt power supply. It's not marked, it cannot be marked in the free body diagram. Since in the free body diagram, the drawing is kinetics and kinematics. It should be dealing with motion and forces. So we'll be marking parameters related to motion and forces. Now we have completed marking all interactions between each of these devices and the environment. Now we move on to marking interactions between these devices themselves. So the only such reaction of significance is the torque the motor applies on the rod. So let's assume that I have wired the motor in a way that when it's powered, the motor will impart a counterclockwise torque on the rod. I call it the magnitude would be tau m. I have marked it and direction as well in red. Another such interaction between these two devices would be friction torque and so on, but I have neglected this one as well since it's of extremely small magnitude compared to the torque due to motor and grip. So all that's required is marked over here, and yeah, that's it for drawing the free body diagram.